So, now let us look at a concept called lattice translation. So, 1D is too restricted, 3D is a little difficult to draw. So, many of the drawing we will make, till now I have not drawn any 3D lattice. So, I have drawn only 2D and 1D. So, most of the drawing which we will do in the class will be 2D for simplicity of drawing, because it is easy to draw it on board or screen. So, let us say that I have a set of lattice points. So, I do not know what is being repeated. Currently, I am focused only on how it is being repeated. So, my focus is on lattice. Then any vector I choose from one lattice point to another is a lattice translation. Any vector from a lattice point to another lattice point is a lattice translation. So, a lattice will have many lattice translation. It can have red translation, have the blue translation, it will have green translation. All these are lattice translations. We also saw, we already saw this, that if we select if we appropriately select two translations. So, we had done that for with A and B, for example. Then we can reach all possible lattice translation by integer combination of these translations. So, that brings us to the concept of basis. So, 2D you require 2 basis vectors, in 3D you will require 3 basis vectors. Expressed as a, the technical jargon you probably know, linear combination. So, if I have selected A and B in 2D, all translations, whatever the translation may be, suppose I have this purple translation. So, I can describe it in terms of A and B. How can I describe it in terms of A and B? Yeah, minus A plus 2B. So, if this is T, T is minus 1 times A plus 2 times b. When I gave example of lattice translation, I should give some counter example also, that vectors which are not lattice translation. So, suppose if I start from a lattice point and end here, this will not be a lattice translation. So, this will not take me from a point to a translationally equivalent point, it is not guaranteed. So, this is not a lattice translation. So, I should not look for, or I should not insist that I am in identical environment if I translate myself by this vector, but the other vectors by a vector, by b vector, or minus a plus 2 b vector, I am going from a lattice point to lattice point, all lattice points are identical. So, I am going by a lattice translation, and I can demand, or I can expect that I am in an identical surrounding. Whatever is the scenery here, I should have the same scenery there. If it is not, then they are not lattice point and it is not a lattice translation. So, that scenery thing which I am telling you is, you can describe it in terms of the neighbors. So, that is another way of defining lattice points. When I say periodic arrangement of points, you can also say a set of points such that all points have identical environment. Yeah.
A by 2, B by 2 be the basis of our example?
A by 2 in the previous one. So, good question. Okay, I will answer in this diagram because that is already messed up. Very good question, because I was coming to that. All not arrangement, let me say surrounding. Now, the question, so first let me see this surrounding thing, identical surrounding. So, this is a lattice point, let us say the lattice point A, and this is another lattice point B, and they have identical surrounding. What do I mean by that? So, if I go by in the horizontal direction by distance A, I find a neighbor. If I go in the same direction, that is horizontal direction, and in the same sense, that is to the right, by the same distance, I should find an identical neighbor. So, that is what is happening, and not only in one direction. So, if I go in the vertical direction, so here from here also I can go in the vertical direction. If I go at in some angle, if I go by the some angle and the same distance, I will again arrive at. So, whatever, so if you look around, if you are a small being walking in a lattice and you stationed yourself here and looked around, you will see certain surroundings, and then if I blindfold you and take you and leave you to some other lattice point, remove your blindfold and ask, have I left you at the same location or a new location? You should not be able to tell. चारों दुनिया देखोगे, सारा दुनिया एक ही है, ठीक. So, that is very very important, all points have identical surrounding. Now, let me try to answer the question which was asked. An interesting question which was asked was, can I not select In this I selected A and B. The question is, can I not select, let us say, A by 2 and B by 2? Let me call them A prime So, can I not select A prime and B prime as my basis vector? What will happen if I select A prime and B prime? So, let us select a vector, let us select this vector. Now, in the unprimed coordinates A and B, this was 2A plus 2B. I should keep putting the vector sign which I am missing. So, please add that. Yeah. So, but what about the same vector in A prime B prime coordinates? 4, it will become 4 A prime plus 4 B prime, because it was half. So, I have to go twice that amount. Fine, that is also a basis, that is also a basis. So, A prime B prime are not lattice translations, whereas A and B are lattice translation. So, in terms of a basis for vector space, both are basis, because both can represent any vector in the space. Here I have a 2-dimensional space, any vector I draw in 2-dimensional space, I can express them either as a primed combination or as an unprimed combination. So, both in that sense both are basis. But the basis vectors in one case are lattice translations and one case they are not lattice translations. And in crystallography we prefer, because calculations become simpler, if we choose the basis as lattice translation. So, that is our choice to make life simpler. So, there is another problem also somebody should point out, means reverse of this problem. Here shorter vectors were selected. What will happen if you select longer vectors?
We won't be able to cover all the points on the lattice by we defined n and m as integers.
N m n is integers, very good. So, that point is very very important, and that brings us to an important classification of these bases also. So, if T is equal to N A plus M B with N and M as integers, give us all the lattice translations. Then we give a specific name to the set A B, that the set A B is primitive basis. Primitive. This will obviously, this a primitive basis has to be made up of lattice translations, because we have seen that if the primed vectors we would have selected, then some integer combinations like 1 a prime plus 1 b prime leaves me in the middle, does not take me to a lattice point from and does not give me a lattice translation. So, problem with a prime b prime was that all integer combinations were not lattice point. The reverse problem which I was telling you, and you answered correctly, that if I select a larger vectors, suppose this a double prime and b double prime. So, a double prime takes me to twice the distance of separation of lattice points in that direction. So, even 1 a prime is taking me to the next to next lattice point. So, this middle lattice point I cannot come by an integer combination, I have to go half a prime. So, that is also an allowed basis, only its name is given as a non primitive basis. Only a subset. It is called a non primitive. A non primitive basis. And we also discovered one more basis which does not fall in this classification, that one is giving me a subset of points, one is giving me all the points, and in the third case here a special example which we considered thanks to you gives me points other than lattice point. It gives me all the lattice points, but it will also give me additional points which are not lattice points. So, because it gives me the points which are also not lattice points and our interest is in lattice points, that is why this restriction or that is why this choice, that why we like to choose lattice translations as our basis, that we are assured if we choose the lattice translations as basis, we are assured that linear combination, integer linear combination of these basis vectors will be lattice points. Whether they are all lattice points or a subset of lattice points depends upon their size and shape, but linear combination has to be a integer combination has to be a lattice point.